Okay, folks, so our topic today is we're going to start talking about three-dimensional figures, specifically prisms. So to start off here, I have two shapes. These are both prisms. The first one, you'll notice you have a triangle on the left and the right side of the object. So this is called a triangular prism. So triangular prism. And then the second one, you'll notice at the top and the bottom, each of those have 6 sides. That is a hexagonal prism. Okay, so why are these both prisms? Well, to be a prism requires a couple of things. First of all, you have to have 2 bases. And with the bases, they have to be polygons. So if you deal with circles, if these were both circles, then you would be talking about a cylinder instead. So the idea of a prism is you have 2 bases that are polygons. Now the 2 bases have to be congruent and parallel. I'll write the symbol for parallel. They have to be congruent and parallel. So for the triangular prism, the left and the right side, those are congruent and they're parallel. Okay, that's a triangular prism. Notice that the other sides, though, the other faces, are not triangles. Notice that the front here is a rectangle. Notice that the back section is a rectangle. Notice at the bottom, now it looks like a parallelogram, but that is a rectangle. So what happens here, you've got this prism. Now the dotted line represents the area that you technically can't see. It's the back or the side. Okay, so you know it's there, but you can't see it. So the 2 bases, in this case, are triangles. So that's a base, that's a base. Well, what about the rectangles? So each of the rectangles is called a lateral face. So for this one, so we'll look at the front here. That's called a lateral face. Lateral is like a side. So if you are playing basketball, if you move laterally, you're moving side to side. So the lateral face, notice that that's a rectangle. Same thing with the back part of this, same thing with the bottom part. If we look at the hexagon, now the bases have to be congruent and parallel. Well, that would be the top, and then it would also be the bottom. So again, that's a base, that's a base. You tend to think of base as bottom, but when you're talking about prisms, it could be left and right. It could be front and back. It could be top and bottom. It all depends on where are the 2 polygons that are congruent and parallel to each other. So in this case, the bases are the top and the bottom. The lateral faces are the faces, the planes that are connecting the bases. So right here, that's a lateral face. And notice that's a rectangle. So for any prism that we talk about, the lateral faces are going to be the rectangles. Those are the sides that are connecting the bases. Okay, now to get even more specific about this, if I look at the edges, these are the segments. In the triangular prism, you've got 3 edges for this base on the left, for that triangle. We've got 3 for the triangle on the right. And then we have the 3 segments, 1, 2, and then in the back, 3, that connect the bases. Those are called the lateral edges. Okay, so here's an example of a lateral edge. That is the distance between the bases. Typically what we're going to see is that we'll be dealing with right angles here. So where this edge is perpendicular to the base, it creates a 90. Okay, or down here, it creates a 90, where that lateral edge, that's another edge, connects to the base. So one of the variables you're going to see for this, we're going to call that that lateral edge is h. That's actually the height of your prism right there. The lateral edge, in this case, that's going to be the height of the prism. Because what that represents is the distance between the bases. So distance between bases. So a lot of vocabulary here. Distance between the bases, that is what we call the height of the prism. Now that's not the same thing as the height of the triangle, the height of the base. That's different. Okay, we'll get to that in a second when we calculate this. In this situation here, so you've got the bases or the top and the bottom. The segment that is connecting those are all these edges right here. These are all edges. Now each one of those, that's going to be the height. So height can be up and down, okay, if it's perpendicular. We're assuming that that would be perpendicular. Height can be up and down, but it can also be left to right because you're connecting the bases. The height is the distance between the bases. The lateral faces are going to be the rectangles. Those are the faces that are connecting the bases. Okay, so this is the vocabulary we're going to be talking about. So triangular prism, hexagonal. Now we'll talk about a rectangular prism in a moment here. But let's look at an example. So we've got the triangular prism, we've got the hexagonal. Three things that we're going to be asked to find. So first of all, let me draw the example. And let's say we'll use a triangular prism. Okay, so EX is example. And let's say, so it looks something like this. So I draw the triangle, and then I'm going to draw, here's the other triangle, which actually I should have made that dotted. Imagine that's a dotted line. And then that comes like that, something like that. And then this will connect to there. And that will connect to there. And that was a horrible drawing, so let me try that again. I'm about to make the same mistake twice. There we go. Okay, so there's the picture, so ignore that one right there. That didn't work out so well. And let's say that this is 10, and this is 10, and this is 16. And we'll say this right here is 23. Okay, the other thing I'll do is I'm going to put some right angles in here. Okay, like that. Three things that we can try to find when we're looking at a prism. First one is called lateral area. And that is the area, we abbreviate that LA. That's the area of the lateral faces. And I'll abbreviate lat, faces. In other words, that's the rectangles. Okay? You'd have three of them in this picture. You'd have the front, you'd have this back portion, and then you would have the bottom. We can also try to find surface area, which we'll abbreviate SA. Surface area is the total area, including the bases. So it's the lateral area plus we include the bases. So we're including the bases. So lateral area would be just for the rectangles, but surface area, imagine that you were wrapping this up as a present, so you would also wrap up this left side and this right side. Those are the two bases. And then the last one that we'll find is volume, which we'll abbreviate with a V. Volume is the amount of space inside, is the amount of space inside. Okay, so there's three formulas for this. And we're going to write these down. So lateral area, we're going to start. This is for a prism. Lateral area is the height times P. H times P. Okay, so what does that mean? Well, P is the perimeter of the base. Perimeter of base. h is the height of the prism. Now this is where you got to be careful, because you might think of the height for the triangle, but that's not the height of the prism, that's the height of the base. In this case, the height of the prism is the distance, it's the segment between the bases. So if the bases are the triangles, the segment connecting them is right here, that's 23, that is your h. Okay, so what we've got, now when I do this, I'm always going to write down the formula, LA equals, I'm going to open parentheses for my two variables. So I need the height of the prism, we got that, that's 23. Times P, P is the perimeter of the base. Well, the base is the triangle. So the base is the triangle. The perimeter of that is you add up the sides of the triangle, 10, 10, 16. So we get P is equal to 36. So the perimeter is 36. And so the lateral area is 23 times 36, which you can type that on a calculator. And what we get is 828. So LA is 828. Let's go ahead and say that this was centimeters for the unit of measurement. So when you write down area, area is the amount of covering. Okay, area, when you think of area, is the covering. Volume is the space inside, area is the covering. So 828, that's going to be centimeters squared. When you cover something, area is always two-dimensional, so it's the unit of measurement squared, 828. Okay, so there's lateral area. The next one is called surface area. The formula for surface area is you take your lateral area, or H times P, which we already know, plus 2 times capital B. So the capital B, that represents the area of the base. Area of base. Now, capital B is the area of the base. Well, the base is the triangle right here. I'm going to draw that triangle. Again, it's isosceles, 10, 10, 16. I need to find the area of a triangle. Well, area of a triangle is 1/2 times base of the triangle times the height. So you see how this can get confusing because you've got all these different variables. You've got different B's and H's. In the triangle, the base is the 16. The height, we do not know. The height, I'm going to draw it right here. I have to draw that height to make it perpendicular to create a right angle. When I do that, this base here, that becomes 8. This is 10. This is my h. I'm going to use Pythagorean theorem to solve this. So h squared plus 8 squared is 10 squared. H squared plus 8 squared is 10 squared. So that's plus 64 equals 100. Subtract 64. We get h squared is 36. Take the square root, I get h is 6. So that's the height. That goes into right there. That's the height of the base of the triangle. So it's 1/2 times 16 times 6, which is equal to half of 16 is 8. 8 times 6 is 48. So the area of the base, that's my capital B. So what we got here for the surface area, so surface area is the height times the perimeter. That was your LA. We already found that. That was 828 plus the area of the base. We have 2 of them because you have 2 triangles. So that's 2 times 48, which is 96. And if we add that up, we will get 924. And again, it's an area, so that's centimeters squared. Notice that that's bigger than the lateral area because now we're also including the area of both bases. So capital B is the area of the base. All right, so we're going to stop the video here, and then we'll pick up with the volume.